A very warm welcome to every one of you. Good evening, my dear students. Welcome to ACE online platform, ACE Engineering Academy. Today, we are going to see about communication systems predominantly pertaining to GATE syllabus and also related with ESC exams, and as far as other exams concentrated also. So, myself, my name is Saravan. I am IES 2011 batch, taking classes in ACE Engineering Academy from 2010. Subjects are signals and systems, communication systems and network theory, predominantly concentrating on communications and signals. So let us quickly go through the session details. What are the things that I am going to cover now and how it will be very useful for you in your preparation. Right. This is a session outline. I will be concentrating on syllabus because syllabus is very important. You have to have a very good grip on syllabus. What exactly you have to prepare. This is a very smart preparation because it is not like previous days. Now you have to be very smart in your preparation. Once you are very clear with what you have to study, how much you have to study, what is the depth that you need to do. Once you have a complete clarity on this, then the percentage or probability of striking an exam becomes very good for you. So it is not that preparing too much, you are not preparing for anything else, you are preparing for a competitive exam wherein you need to get a good job or get into an IIT or an NIT. That is your first target. So for that, the starting step is understanding the syllabus clearly. Once we are done with this, how much is the weightage you are getting from this subject? So it is not that you prepare your subject perfectly, but you get some chota 3 marks, 4 marks. That is not much useful for you. You have done a lot of hard work, and that hard work should be utilized in the correct way. When it will be done? When you have a good weightage. So you should know in your syllabus what are the areas where the chances of getting questions are more. I am not telling that you leave these topics or you prepare these topics only. That is not my purpose. My purpose is to tell the chapters or the areas where the chances of getting the questions are high. That is what is required for me. So for that purpose, we will be seeing the weightage also. So I have done an analysis of last 4 years question papers, and my expectation on certain topics, I am going to tell it. It's not that it will come with 100% probability, but 80 to 85% chances is there. That is more than enough. Okay, 50% chance itself is very good. I am assuring that it can be up to 80%. Okay, you can take that. And then the preparation strategy. So what strategy you have to follow? So I have given the weightage, I have given the syllabus, then you have everything with you. It is just like, it's a full meal for you. Now when you start eating it, what should be the procedure you have to follow? So will you take the hot curries ones or the sweet ones? These things should be very clear for you. And the digestion process should be good. So you eat everything, at the end you don't have a pan. Then what will happen? Digestion will not be proper. The same thing here also. So you have to eat everything, you have to complete the total syllabus, but a perfect strategy is required. It is just like a correct pan at the end of the dish. So if you can do that perfectly, then the digestion also takes place very neatly. That means the understanding of the subject and attacking the question will be in the correct state. So that is what is helping you in preparation strategy. And finally, some reference books which will be useful for you in your preparation. So all these things would be I would be covering in today's session, this 1 hour session. So sit back and see what are the points that I am covering here. Okay, right. Let me go into the first part, the syllabus part. I have taken the syllabus from IIT Kharagpur website, whatever the syllabus that is mentioned for this year examination. That means GATE 22 exam that is already completed. So the same syllabus will also be there for the next year. I don't think there will be any updates. Once the notification releases, maybe if at all it is there, we will update at that time. But as of now, this is the syllabus in your communications. Now in the syllabus, they have mentioned under one section, communication systems. So it's not a small subject, it's a pretty big subject. Frankly speaking with you, communication systems includes 4 subjects of your semester. If you take the engineering curriculum, most of the engineering colleges in our country, we have random variables, random process, which might be coming in second year first semester. Then analog communication schemes, which comes in your second year second semester. digital communication techniques, which comes in third year first semester, information theory and coding, it comes in third year second semester or fourth year first semester as an elective. So the combination or amalgam of all these 4 subjects is our entire communication system. So it is not a small syllabus at all, 4 subjects of your engineering discipline. So obviously the time you have to spend here and the weightage you can expect from this is quite large. Okay, first keep that point in mind. Now, generally we start with analog communication because communication system started with analog communication. Okay, so predominantly the starting of your communication engineering is analog communication. Now, if you see the analog communication part, these are the different areas we have. What are these areas? These are the things which are mentioned in the syllabus itself as lines. Okay, I have taken the same lines and pasted here, nothing extra. I will explain what you have to study looking into these points only. Now, first part is amplitude modulation and demodulation. So what are the points that are there in amplitude modulation and demodulation? Let me write it out here. So when you take amplitude modulation and demodulation, you will have standard amplitude modulation, then you will have double sideband suppressed carrier modulation, then you will have single sideband suppressed carrier modulation and vestigial sideband modulation. Along with this, frequency division multiplexing. So these are the areas that you will be concentrating on. Now, in all these areas, you have to concentrate on the modulated signal expressions, then the spectrum, then the power calculations, the bandwidth requirements and modulation efficiency. I am writing here, okay. And modulation efficiency. So whatever the numerical that comes will be predominantly 60 to 70% comes on this area only. Okay, so these are the areas which should be of primary focus. So depending on the modulation scheme you take, it can be any of these things. Each modulation scheme, like standard AM you have taken or conventional AM, you have to prepare yourself on modulated signal expression, the spectrum, the power requirements, the bandwidth requirements and the modulation efficiency. These things has to be taken care. After completing this, you have to see different modulators you have and demodulators. That's it. So these are the points that you need to focus on. Is it clear or not? So this part comes under the standard AM or conventional AM. That's what is written here, amplitude modulation and demodulation. That one line is this entire part of the syllabus. Okay. Now, second part is angle modulation and demodulation. Now, what is angle modulation and demodulation? That means he is asking you to prepare frequency modulation and phase modulation, FM and PM schemes. Again in this frequency and phase modulation, you have to refer S of t, modulated signal expression, spectrum, power requirements, bandwidth requirements, modulation efficiency, modulators and demodulators. So this will complete the total angle modulation schemes. Okay. Now he has referred here spectra of AM and FM means a modulated signal spectrum of all different cases. So you have to do a study of different cases. Just a moment. Yeah. You have to do study of different cases. So you can take a message signal as a single tone signal, study of different message signal cases. So So you have to study single tone message signal case, combination of single tone message signal cases, generalized message signal cases. Try to study as much as possible in a generalized fashion. Now the common mistakes which students do here is they will memorize the results. Memorizing the results and attacking the question is very good in time-based exams. Time-based exams, from my point of view, is like there is a one question for 1 minute or less than a minute. Such examinations, examiner also does not do much research. He will give direct questions. If you know the formula, substitute and get the answer, that's it. These examinations, for example, are like ESC prelims exams. You can easily do it, the same syllabus, there is no change. So at least 4 or 5 questions comes from this topic. Easily you can answer those 4 or 5 questions, no doubt on that. But when you are going for GATE like a conceptual examination, it is not about substituting in the formula and getting the result. That is not the case. You have to use your brain, apply the concept and then get the result. It does not mean that it does not depend on the formula. Obviously it should depend on the formula, no doubt, but the way how you apply there will be different. So that is how the questions will be framed in your GATE exams. So it will not be straightforward, but you will be using the same formulas. So how cleverly you do that is the final result. Okay, keep that point in mind. So that's the reason I am telling you, those who are seriously preparing for GATE examinations, don't simply memorize the formulas, final results, that is not correct. Prepare, understand and then make your own set of points. That will help you a lot in your examination. Now, this is done, second one is done, spectra of AM and FM is done. Last one is receivers. Now, we have a standard receivers. Standard receivers. So, under this standard receivers, we are having tuned radio frequency receiver, we call it as a TRF, and super heterodyne receivers. And super heterodyne receivers. These are two receivers which we use very commonly. Now, these receivers are generally studied keeping in mind AM radio and FM radio. I should be very frank with you, this topic particularly for GATE exam is not that much in terms of weightage. Maybe maximum 1 mark, but other competitive exams, time bounded exams, definitely 2-3 questions are coming. This is a very, very important topic, especially when you are going for any core sector company interviews. Because when you are preparing for one exam, one way or the other it helps in everything. These topics are very much important for 1-2 marks bit. This topic, as far as my expectation is concerned, you will not get a question in GATE, very rare, and even if you get 1 mark. But 2 or 3 at least interview questions if you go for any core sector company. If you are going for a communication based company and Qualcomm is there, any communication or telecom based company, definitely they will put 1 or 2 questions on this. At least they will ask a frequency range of AM and frequency range of FM, common question obtained. Okay, now because you are watching now, I just want to put a one simple question. You can comment, okay, you can tell your result if possible today itself right away or maybe tomorrow or day after tomorrow. I am telling you one point, you just reply to this. If you see your FM radio, what is the frequency of FM radio? FM radio frequencies are 88 megahertz to 108 megahertz, correct guys? Girls and boys. Correct or not? Everyone knows that. Some who doesn't know this also, it's okay. At least now know it. 88 megahertz to 108 megahertz is FM range. Now, you tell me 2 or 3 radio stations. 2 or 3 radio stations. I am staying in Hyderabad. So here we have plenty of FM stations. If you turn on your mobile and see, I am getting 2-3 stations. I am naming them. I am writing the station frequencies 91.1 megahertz, 90, 8.3 megahertz. I am taking only two, the space is not enough here. So I am proceeding with these two frequencies, okay. Is it clear? Now my question to you is, if you take the value that comes after this dot, these values if you identify, most of the times this is an odd number. This is one of the question myself I only asked in one interview. When I went for one of a PSU, they called me for taking interview for the students. So they asked me to prepare some question set and we can give it to the panel people there, or I can also ask the questions. These are simple things which we expect. Even in ESC mains interviews also these type of questions are asked. Now my question to you, I am repeating, you take at least 4 or 5 FM stations which are there. You see the number that comes after this dot. Most of the times this number that you are getting after the dot will be an odd number. I am telling most of the times, not every time. Please don't change my question. Most of the times this number which you get after dot is an odd. You tell me why is that number odd, that's it, okay. If you are able to tell right away, very good, you know the answer. Otherwise please try it out, you will understand. There is a lot of conceptual answer in that, it is not a joke, okay, right. Now these are your topics related with syllabus present in analog communication systems. Done? Now let us go to the next part. Syllabus is not done, I am telling one by one, because I told you 4 engineering subjects are there in the total syllabus. 1 engineering subject is done. Now random processes, strictly speaking the heading should be random variables and random processes. Very, very important and interesting subject. Generally in your engineering curriculum it comes in second year first semester. Now the problem with this subject is, it is completely related with the probabilistic theory. Mathematics has so many things, right? Calculus, we have calculus, geometry, algebra, trigonometry. It will get divided into several branches. There is one unique branch of maths that we call it as statistics, okay. This subject is more or less related with the statistics theory. So you know the terminology itself is totally different. So you have to get acquainted with the terminology to proceed further and understand that particular subject. So that is the problem with this subject. If you are clear with the terminology and the way you understand the question is clear, then you can proceed further. Now what are the topics he is asking here? Autocorrelation and power spectral densities, properties of white noise, filtering of random signals through LTI systems. These are the only 3 lines he mentioned. Now if you study only these things, or if you start with this first part, autocorrelation functions, gone, your mind will be gone. It's real, it's not so simple topic. What you have to do is, you have to understand the starting part of it, fundamentals of it. The fundamentals of this starts with single random variable. It starts with single random variable. That means you should know what do you mean by a random experiment. So what do you mean by a random experiment? An experiment whose result cannot be determined before performing the experiment. Best example is tossing a coin. When you toss a coin, what will happen? Can you tell before tossing a coin every time it is head or tail? No one can tell. Na. If you are telling, you are very lucky, that's all. People will tell you that you are the luckiest person in the world. No one can tell with 100% probability, correct or not? So that type of experiments where probabilistic theory comes into picture is called as a random experiment. Now under random experiment we have single random variable and calculation of statistical parameters like mean value, square value and variance. Of course standard deviation, sigma. So once you are clear with this single random variable and express what is the probability density function and probability distribution function, then we can determine these parameters. Okay. Now Once this part is completed, then you will have joint random variables or multiple random variables. Concept of multiple or joint random variables. That means at this present engineering level, BTech level, you will study about two random variables cases. So here we will study joint probability density function and joint probability distribution function, capital F of xy. So once you study single random variable, these are the statistical parameters we have: mean, mean square value and variance. When it comes to multiple or joint random variables, then the statistical parameters that comes into picture are expectation of xy, which is nothing but correlation between the two random variables. We write it as COR between x and y. And one more important parameter is covariance between the two random variables. We write it as COV. Now, at this stage, one headache topic comes into picture. That is what is called as independent random variables, uncorrelated random variables, and orthogonal random variables. You refer any question paper, there will not be a question without these three words. Confusing. Confusion can be overcome only with clarity. So what is the difference between these 3 points? What do you mean by uncorrelated random variables? What do you mean by statistically independent random variables? And what do you mean by orthogonal random variables? So these things comes into picture when you discuss two random variables concept. So these are all the points which are preliminary to understand this syllabus. In a GATE syllabus, they gave only these things. If you study these things, it will be like a story only. Story reading and going. There is no comprehension there. There it is numerical. So you should know about these things. So you have to divide this into parts. First part is single random variable. Second part is multiple random variable. And third part is parameters, correlation, covariance, and the concept of these 3 points: independent random variables, uncorrelated random variables, and orthogonal random variables. Done? Once you are done with this, then comes your, let me change the color, autocorrelation functions and cross correlation functions. And power spectral densities. Only fundamental parts, then only you can touch this actual syllabus. What do you mean by autocorrelation function? What do you mean by cross correlation functions? And what do you mean by power spectral densities? Now, all these is a concept based on random variables. These are mostly concepts based on random processes. So we extend our concept of random variable onto a random process. So what do you mean by a random process? I will tell you one simplest example. You and your friend are playing a game. Okay, your game is tossing a coin, that's all. So you will toss once, your friend will toss once. That is a random experiment because you don't know whether it will be head or it will be a tail. Over. Now, you do this activity every day in a year. 365 days you do it. That becomes a random process. So what you are doing? You are doing the same random experiment as a function of time for certain period. That is what we refer to as random process. So in this random process, there are different categories, like wide sense stationary random process is one of the most famous category. Wide sense stationary random process. So why we call it in this way? What are its properties? that study comes on this area. Now once you do this, then you take a random process, give it to an LTI system, observe the properties at the output. Means x of t is a random process, it will have autocorrelation function Rx of tau, it will have power spectral density Sx of f. Output will also be a random process with some autocorrelation function Ry of tau and with power spectral density Sy of f. Now what is the system? System is given to you as linear time invariant system. System is LTI. So whenever you have a system, it will have some impulse response h of t. Finish. So what is the response of LTI systems? Autocorrelation functions. What will be the autocorrelation functions at the output and what will be the relation on power spectral densities at the output? How you can determine power of input and power of output. So this is entire random process. So this is what he has given here. Autocorrelation and power spectral densities, that is one set. Properties of white noise, filtering of random signals through LTI systems. So this process is what we call it as filtering. Now in this they have included one exclusive topic we have seen there also. This they are referring to as white noise. Strictly speaking, it is additive white Gaussian noise. So A represents additive. Additive means what? The noise that you are considering in the channel gets added with your modulated signal. Only additive noise, we don't study about multiplicative noise. That you will study in your higher studies. Then you have white. What is the meaning of white? White means white color. White means what? The meaning in our communication systems is this noise does not differentiate low and high frequencies. It sees everything equally. That means whether it gets added with low frequency signal or it gets added with high frequency signal or any type of signal, the effect of noise on that signal is same. That is the meaning of white. Okay, their power spectral densities is constant for all frequencies. And finally Gaussian noise. So you are using a Gaussian random variable to model the noise. So these all part clubbed together is your engineering syllabus in one semester. That is one part in your communication system syllabus of GATE examination. And the most important and the toughest of all. I should tell you frankly, because when you are doing your preparation, you should allocate time as per the syllabus and weightage also. This is one part of the syllabus which is taking more time as well as giving more weightage in your exam also. So that is the reason, try to prepare this subject in a very systematic way. If you are having a good fundamental in your engineering college, okay, but otherwise be very careful with this topic. Okay, you have to spend more time. That is what I want to tell you. It is not so simple. Next, let us go to the next part of the syllabus. It is not yet completed. Next part of the syllabus is digital communication. Now the present trend is everything digital. So basically what happened is, just let me focus you on that. Just don't go away. I mean, I'm not distracting you from the actual one. Just want to focus a little bit. Till 1940s, 1950s, you know, this is all in war era. You know, the First World War, the Second World War, all these things happened during that 1880 segment to 1950 segment, the 50-60 years. And this is an area or a region where scientists are hugely celebrated. Means you see this atom bomb, that is an application of a scientist only, na? So whatever that energy E equal to mc square concept was practically proved that time. And not only that, many things like you take biomedical, especially the Germany related wars, they used so many drugs to make their soldiers highly powerful. They did not even sleep for 7-10 days. You can see these in YouTube videos also. If you see this National Geographic channel, they will give you these things. So how these wars are built up? These people, you know, they they took these injections and did not even sleep also. That's a beautiful biomedical application. It should not be used like this, but you know, the scientist applications have come in that era. So this World War, all this thing is done, but the problem what happened is the economy came down completely. So what happened is, you know, the engineers era has come, started from 1950 plus onwards. So what is the work of an engineer? You have to convert the scientist, whatever he has done, that he will not give any application, he will tell some story. That story, whatever he tells, you have to convert into an application. So applications started to multiply. Refrigerators, air conditioners, washing machines, microwave ovens, cellular communication. It started at 1970s in developed countries. We saw mobiles in early 2000s because we are quite far away from the technology. Right now we are entering into new segments, 4G, 5G. So you know that this era which you are seeing now is a scientist, not scientist era, it's an engineer's era. Means application, wide set of application. So when engineers are there, huge money, because we generated lot of revenue from the public. So that is how the scientist era has got converted into an engineer's era. Now purely applications, right? Now because these applications multiplied a lot, the problem arose in terms of storage of data and retrieval of data. So analog part, if you see, if you take simple example, maybe in your childhood, or you can ask your parents, they might have a device called as Walkman. Walkman is a device where you need to keep cassette in this and listen the song. You tell me that cassette you have seen, it's a magnetic tape cassette, that brown color tape used to be there inside. And the tape can contain only maximum 6 to 7 songs, not more than that. That means what? The storage cannot be more, and it consumes more space. More space means my logic is storage purpose. If you want to keep one cassette, you know, you have to keep it in box and then keep it in a that almara or something. So it takes some space for holding that. So the storage inbuilt capacity is less, and physically is also it is taking more space. To transport it is another headache. So these things has become a big headache when people started to use more and more applications. So what happened? We started to divert from analog to digital communication. There these topics have come into picture. So in digital communication, what is happening now? You have a pen drive which is able to store terabytes of data. Previously gigabytes itself means if you have 20 GB hard disk, that is a big one. Now 20 terabytes is also not that much. Huge storage space, very small space. I can just keep my pen drive in a pocket and go. It's a terabyte storage. So how many songs you can store in that single pen drive? From 1980s you can store all the 20-year songs in that one pen drive. So you see how much compressed the storage space is, and will it require any physical storage? You can just keep it in a pocket and go. So storage became very, very simple, retrieval of data became very simple, and third important thing is processing became very simple. So you just need a digital processor for converting your data, because obviously the final output, the song which you are hearing is analog, but the storage format is digital. So you need to convert digital to analog at the last stage. Starting stage you need to convert analog into digital. So these are nothing but your microprocessor. What is a microprocessor doing? It's the same thing. That means because of this high speed microprocessor technology enhancements, we are able to process the data very fastly. So storage, retrieval, processing became very, very efficient with digital communications. So from 1980 onwards, every university started to develop digital communication subjects. So there onwards, engineers' importance has become much, much more, especially branches related with communication engineering. If you see the old IITs, you know, they don't have even EC branch. They used to call it as electrical engineering. EC is one of the subset of electrical branch. So this based on the applications only. It's not that they did not give importance to EC engineers. Every engineer is having his own importance. Application perspective I am talking. So then this digital communication came into picture. So what you are doing now, this is one subject in your engineering branch. In every engineering college, one branch, no doubt on that. Now, what are the different topics involved here? So your digital communications, when we talk, is mainly divided into two parts. One is called as baseband data transmission, and another one is called as band pass data transmission. Broadly, the segment is divided into these two parts: baseband data transmission and band pass data transmission. Now, how this thing you can remember? Very simple. You have a telephone connection, you are making a call, that call is going through a landline cable. If you see a physical cable, it comes under baseband data transmission. So whenever you talk about baseband data transmission, medium is a physical cable, that's it. Physical cable means it can be twisted pair cable, coaxial cable, optical fiber cable, all these things comes under this. Now under this we are studying a pulse code modulation, differential pulse code modulation, delta modulation, and adaptive delta modulation. That's all. So these are the topics that comes under this side. Now when there is no channel means what? No physical channel. Your transmission is through free space, that means mobile communication. You make a call, what will happen? It will connect through a cell site and then the routing will take place. That means the basic medium that you are considering is air. So here air is the medium of transmission. Free space channel, air. When it comes to this band pass data transmission, we are having binary modulation schemes like binary ASK, binary FSK, and binary PSK. Then the enhanced versions, M array PSK schemes and M array QAM schemes, QAM, quadrature amplitude multiplexing. So these are called as a higher order modulation schemes. We design these techniques so as to minimize the bandwidth required for transmission. So this is one very, very important area. Now I will ask one more question. First question I already asked you. This is the second one. Which modulation scheme you are currently using in 3G transmission for mobile communication? Just look out. This is a very good interview question. Mobile communication. I am telling the generation also, 3G communications, 3G networks. What is the modulation scheme used? And we are going to launch 4G as well as what is the modulation scheme used? Most of the current networks we are using 3G only. 4G some have developed but not complete. But try to see what is the modulation scheme we are using. Okay, very good interview question. So these are all the points that comes under band pass data transmission. So your syllabus is predominantly on these areas. See this, PCM and DPCM comes under band pass, and then ASK, PSK, FSK, QAM. Particularly they told bandwidth. Why? Because very, very important parameter. Bandwidth, you know, in communication is like money. So generally no one wants to spend money, they need to get the work done, they will spend less money. If 100 rupees you are spending for some work, if you can get that work by 50 rupees, you will go to that person only. Less money, more work. Bandwidth in communications is also like that. You design any modulation scheme, primary target of modulation scheme is to keep as less as bandwidth. You tell a modulation scheme where sir, this signal to noise ratio is very good, it's an extraordinary modulation scheme. Finally what they will ask, what is the bandwidth? Like you are buying a vehicle, it's a common question. When you go to a showroom and buy some car, that person, that manager, sales manager will tell so many points. This is having artificial intelligence, machine learning, so many new technologies he will tell. It will automatically stop, it will give so much safety features are there. Finally, what will be the customer asks, what will be the mileage? Correct or not? in terms of mileage in communications is bandwidth. So bandwidth for a given modulation scheme should be as less as possible. Then that modulation scheme will be a biggest hit. That is the reason exclusive priority will be given to bandwidth. Okay. Now, one important topic here is ISI, inter-symbol interference. Generally what the students feel is, when I ask ISI, sometimes randomly when we ask some questions, they tell it is a part of a noise. ISI is not noise, be very careful. It is a default coming in modulation schemes because of pulse spreading effect. So this ISI, whenever it comes into your mind, always remember this pulse spreading effect. When you do transmission using rectangular pulses, there is a heavy chance that one pulse will get interacted with the next pulse, or its previous pulse, next incoming pulse. So because of this interaction happening there, the pulse spreading takes place. Because of this, the probability of error will increase. So that is what we are referring to as inter-symbol interference. This has to be reduced. Okay. Then MAP and ML detection algorithms, matched receivers, matched filter receivers, and signal to noise ratio and BER calculations, very important. So this part will come in both baseband as well as band pass. What basically happens here is, you do whatever you like, means you will have your received signal, which we generally write as R of t, which is your modulated signal S of t added with noise N of t. So when it comes at the receiver, the signal component and noise component will get added together and come at the input of the receiver. Now the processing of this signal and noise will take place, and we sample the data at t equal to TB seconds. That means whatever this output you are getting here is R naught of t, means it is containing the processed signal component and noise component. Is it clear or not? Okay. Now this part is given to a very important device called as threshold detector. Generally it is represented by this symbol. Saturation symbol that you represent in your op-amps, almost the same symbol. Now this threshold detector operates with threshold voltage, VTH. Okay. Now what we do is, if this received voltage R naught of t at t equal to TB happens to be greater than or equal to VTH, we tell that the decoded bit is bit 1. If this R naught of t happens to be less than VTH, we tell the decoded bit as bit 0. Generally this is the algorithm that we follow. Okay. Then what will happen? Automatically your bit sequence will be developed at the output, which we write as BK. Now there is every chance that a 1 transmitted may get received as 0, or a 0 transmitted might be decoded as bit 1. Correct or not? That is what we refer to as a probability of error. This is one part of a story. Means you are transmitting binary data, then doing some operations at the receiver, giving it to a threshold detector, based on VTH, generating the bit sequence and finding the probability of error. Story over. Now what is very important here is, actual story starts here. What we do is, we try to optimize this value of threshold voltage. That means you need some algorithms there optimize the value of threshold voltage. So what is the meaning of optimizing the value of threshold voltage? You should see for what value of threshold voltage the probability of error that you are getting here automatically gets minimized. Okay. Now the algorithms which help you to get this V optimum is MAP algorithm. So using MAP you will get V optimum. Getting V optimum will calculate probability of error which automatically gets minimized. So this part of structure is done using MAP, maximize a posteriori algorithm. Okay. Another version of MAP is ML, maximum likelihood decoding algorithm. There is a definite question on this in next year, no doubt on this. Every year one question will be on this. And I am really telling you, it is not as simple topic as you feel, because there is no predefined formulas. You have to think and do it, and questions are simple only. The way how you think is very, very important. That is the very important part of the entire syllabus. Okay. So if you can get a grip on this part, then you will feel very comfortable with digital communications. And it's one of the very beautiful part of the entire digital communication systems. Because even for the faculty point of view, we can deliver so many lectures, but if students cannot observe that, we also feel very bad. So it's in fact a very difficult situation for us to explain this topic clearly also. And this is a very, very important part of the syllabus, definitely covering questions from this area. Okay. So this is what your MAP and ML does. So this algorithm, don't think it is only used in this part of the system, it is also coming in this area. So depending on the question framed, you have to answer that correctly. So that completes your MAP and ML detection. Now you have two receivers, we call them as correlation receivers and matched filter receivers. These are synthesis of optimum receivers. So here we deal with optimum receivers. Optimum receivers means what? Receivers operating with optimized value of threshold voltage so as to minimize probability of error. So two receivers that comes under optimum receiver is matched filter receiver and correlation receiver. In your syllabus they did not mention correlation receiver, but it's a continuation part of matched filter receivers only, very important. And finally, calculation of signal to noise ratio and bit error rate. So these are different areas that is coming under digital communication part. Still the syllabus is not completed, stay with me. The remaining part of the syllabus we have is information theory. It is also one subject in your engineering, but luckily IITs, I don't know, they might have felt the syllabus itself is overflowing here. So they limited this information theory part to a very, very small extent. If you actually see the syllabus that is there in your engineering studies, 5-unit syllabus is very, very huge. Now they did not take every part of it, but they have taken the most important part of it. So what are these points? It is covering about entropy, mutual information and channel capacity theorem. That means first part here is you should understand what is the meaning of information and what is the meaning of entropy. These are the fundamental things. Information is represented by I and entropy is represented by H. Okay. Once you know this part, then we have different types of entropies. Like entropy of the source H of x, entropy of the receiver H of y, joint entropies H of x comma y, conditional entropies H of x given y and H of y given x. So these are all different types of entropies that you need to study. So once you have grip on this, then what is the information transfer happening from transmitter to receiver? And what is the capacity of the channel? These two are specifications for a given communication line. Okay. Now once you are done with this, then you are having different types of channels. Like we have lossless channel, we have deterministic channel, these different types of channels, okay. And then we study about channel capacity theorem. So channel capacity theorem beautifully tells about the trade-off between signal to noise ratio and bandwidth. That is where the channel capacity theorem is very, very important. Trade-off between bandwidth and signal to noise ratio. This is one very important and practical application of this channel capacity theorem. Even when you go for interviews, this is also one area where frequently questions are asked. Okay. So this entire part comes under the syllabus of information theory. Okay. So these things you need to keep it in your mind, and relatively less weightage as well as less time for you to focus, because you need not spend hours together only on this part. It is a very limited syllabus and very effectively you can prepare. And extra things that fundamentals you require here is Bayes theorem, very, very, very important. It comes very frequently here, and binomial distributions and Poisson distributions. Most of the times numericals framed will be on this area. Binomial and Poisson distributions. Clear? So this is what your information theory part covers. And the last part, I am coming to the end of a syllabus, which is your fundamentals of error correction. So here they did not do much headache on the syllabus, they kept very, very small part. Whatever the information theory part you have studied, the extension of that information theory part is coding. So basically when you talk about this coding, you are having source coding techniques and channel coding techniques. Both are very, very important, especially channel coding is very, very important in present day technologies. Most of you might have seen this. Suppose you are doing some payment, like you do your payments through online banking. So when you do payment, what will happen? It will ask for an user ID and password. Immediately when you press enter after typing the password, that entire 8-bit or whatever the password you have typed there will get converted into 128-bit. So it becomes very, very tough for an intruder to capture your password and do some unfortunate thing there. So very, very important part. Now your coding techniques concentrate only on channel coding part. So here we are covering about linear block codes and matrix representation of block codes, that's all, only that part. Matrix representation of block codes. And one error detection algorithm, it is not an error correction algorithm, cyclic redundancy check. So using this cyclic redundancy check, we will confirm whether an error occurred or not. If it occurs, we ask for retransmission. If it did not occur, you take the data as it is. So this is a part that is covered under last. So this completes your total syllabus. As it is, the lines which are given in the IIT Kharagpur website syllabus, I have taken here. I did not write anything here. I have just explained what are the things that you need to study. So each part of the syllabus is very important. I am not distinguishing one topic from other topic. Relatively all are important topics, but when it comes to weightage, let us try to differentiate little bit so that you can apply smart way of preparation and save some time. Okay, so this is the first part. The syllabus part is done. Exclusively I have covered all the points. Okay, Now, when it comes to weightage, I am giving topmost importance to these two topics because I am in this teaching sector from last 10 years and I have seen the way how the communication papers are coming, especially for GATE examination. Initially the emphasis is on analog communication. Day by day, year after the year after the year, they converted slowly to digital communications. Now the questions that are coming are on mostly random variables and random processes. So that is the reason when it comes to the weightage, I have given the top preference to random variables and random process part. So you can expect at least 4 marks from this area. Most probably 2 marks questions. And this digital communication covers at least 3 marks or more than that, 3 to 4 marks. So the majority of the weightage that is coming from communication syllabus in GATE examination is from these two areas. So almost 7 to 8 marks comes from this area only. Now coming to analog communication, maximum 2 marks. Coming to information theory, generally 1 mark, very rarely you will see a 2 mark. And coding also maximum 1 mark. So if you add all this, total weightage is here it is 4 marks and this is 4, 8 plus 3 or 4, 11 to 12 marks. So the total weightage you are having here is around 11 to 13 marks in GATE exam. ESC exams, equal priority to all the topics will be given. They do not even miss one small topic. So it will be more questions as well as equal weightage on all topics. So there I need not distinguish these topics and tell you. You give equal importance to all topics. But in GATE examinations, this is my go. Most of the times nowadays, more importance is given to random variables, random process and digital communication when compared with the remaining topics. So on an average, you can expect around 12 marks coming from communication systems, out of which 60 to 70% will be from random variables, random process and digital communications. Okay? So this tells you about the weightage part. Now what is a preparation strategy you have to follow? Very simple, very effective. I have taken only 5 steps here, just to concentrate on these 5 steps. Done. First step, focus on fundamentals. Improve your fundamentals first. What are the fundamentals you require for communication systems? You require max fundamentals, simple max fundamentals, cos A, cos B formulas, sin A, cos B formulas, integrals, derivatives and fundamentals of your signals. So what is step function, impulse function, correlation techniques, convolution techniques, how you are taking the Fourier transforms for fundamental signals, how are you representing sin and cos transformations, these things I require. So focus on fundamentals. The fundamentals here are from mathematics and signals and systems. Most of the analog communication part will be extension of signals and systems only. So first get a grip on that. Okay. Next, second step is you split your syllabus into smaller parts. That is what I have clearly showed you there. Once I have taken a syllabus line, I have divided that into smaller parts and explain to you what are the possibility of questions coming from different areas. So that is what is the second step. Don't read subject as it is like that. Split, split, split until it is not possible. Atomic level splitting is required. Then you proceed with each and every topic. So this is a one very useful step because you will clearly understand at which point you did not understand that part also. So you can keep that aside and you can discuss with your faculty and get your doubts cleared very easily. And you can understand and you can answer the questions in a very safe zone. So keep that point in mind. Third step, prepare bullet points. This is very, very important. Bullet points means bullet points only. Don't write copy paste entire notes. I have seen some students, it can be from online or it can be from offline, whatever the mode of preparation might be. Whatever the notes we tell in class, entire copy paste in the notes, that is okay up to certain extent, but don't repeat the same thing again and again. You have to understand the concept and get the important points noted very, very clearly. That is what is called as bullet points. Next, time bounded preparation. Okay, you are very interested in this subject, but is that you have to prepare 6 months, 5 months together only on one subject? You will become master of communication, but you will fail in GATE exam. That should not happen. So a time bounded manner should be there. Maximum 1 month, not more than that. So how many hours you have to spend per day? That depends on your talent. I cannot assess your talent. It is your self analysis. But maximum duration you can allot is 1 month, not more than that. Okay. Then revise and improve. So this is also one very important step. Once you complete your total preparation, don't keep that subject aside. Once you are done with that, you will feel confident, but refer that at least once in 3 weeks. Once in 21 days, if you refer, there is no chance that you will forget that subject. So that is also very, very important. Revise and improve. Okay. So if you can do these 5 steps perfectly, not only in my communication system subject, any subject that you prepare, definitely you can master your preparation. And these are the things which you need to keep in mind. Overall, I am covering these points. Okay. When you are preparing for GATE examination, especially for GATE exam, focus on these things. It is a success formula which is told by many of the GATE rankers along with me. I have also done the same thing. Okay, see here. Preparation of at least 6 subjects. What are the 6 subjects? You decide. But you need to prepare 6 subjects from your total GATE subjects. Complete preparation by November end. Don't go above November. If you are going means you yourself are keeping in a problem. Because your mind can take it, but it cannot reply back. So even if you study, there will be no use. That is the meaning in my statement. Because don't expect GATE questions to be simple. They will be complicated. Think in that way and go. So don't do preparation after November. Whatever you have completed by November end, that's it. You have to revise them. That is the next point. Revise revision time for 2 months. Entire December and January should be complete revision of these 6 subjects. Performance should be to the maximum extent. Then writing individual subject tests. So as a part of our curriculum, we give individual subject tests as well as grant tests. So don't miss them. If you are a part of our curriculum, that is done. Otherwise also, you can enroll for these subject tests. So you can enroll for individual subjects as well as grant tests. Complete them in time. That is the next point. Writing grant tests and individual tests, and improve from your mistakes. So don't think that you have made a mistake and you think only on that mistake and lose that complete day. You are doing mistakes at this level is very important. You need to correct them. Then in the final GATE exam, you will not make much mistakes. So that is the motto of writing these exams. And avoid overconfidence. That is also very important. Just because you know the subject very well, don't think about only that particular subject and keep discussing with your friends. Okay, this is not a good strategy. You know, I have seen so many students, like nowadays the communication has become very easier. You have so many WhatsApp group, Telegram groups, all these things are there. People will be posting questions on that, and those people who know those answers, they will be immediately answering them. Actually, that is not a correct strategy as my personal opinion. If you know the answer, that is fine. But don't reply back immediately if you are a seriously preparing student. If you are doing that, you are wasting your own time. Keep that point in mind. You keep some slotted time, like 1 hour a day for Telegram channel or 1 hour a day for a WhatsApp channel. You discuss with your friends, you post, you give replies, anything you do, but 1 hour, not more than that. If you keep on doing this, you are spending more time on replying queries or asking queries rather than developing your own subject. So that is the reason I strongly recommend you see the channels, be a member, you participate in everything, but stipulated time bounded manner. Okay, right. And these are the books for your reference. If at all you want to refer, because once we give you the entire material, or if you are a student enrolled with us, if you are going for online, offline, or this deep learn videos, then everything is covered. No need of any external books. But still, if you want to refer any textbooks, okay, you can refer through these books. These are the standard books. I did not mention all the books. Predominantly model of questions coming in GATE exams from these books. Communication System Engineering by Prokis and Salehi, standard textbook, especially for digital communications. Principle of Communication Systems by Top, Schilling and Saha, this is also for digital communication. I told you, emphasis should be on random variables, random process and digital communication. So these first two books are very, very important for that area. And last is that analog communication part, Simon Hackin, our standard author. So these three books are enough. If at all you want, you can also refer book by B.P. Lati. Both analog is there and digital is also there. This is also one very good book. So these are more than enough for textbook reference. Don't spend more time. You have to spend your time in a focused manner. So be very, very clear with that. Okay? So that's it from my side. I think I have completed in time, and thank you very much, and I wish you a very best for your preparation. So be very focused. Time is very important. Give value for time, then definitely you will have very good result in the coming years. Thank you and good night.